children, welcome to Zero Panic Maths. In today's session, we're going to continue our discussion on algebraic methods of solving a pair of linear equations. If you remember, in the last session, we have discussed a way of finding the solution for pair of linear equations, that is a graphical method. Okay, but what was the disadvantage of the graphical method? That we are now switching for an algebraic method. Okay, so what is the disadvantage of that? The graphical method actually gave us the solutions, but those solutions were only for the smaller values. Okay, so if there is a larger coordinate values that we have to point on the graph, then it will be very difficult. Okay, because we have seen some examples where some small coordinate values can be represented on the graph, but for the larger values it is difficult to point or plot those coordinates onto the graph. Okay, and along with the larger values, it is also difficult to represent the non-integral coordinates like some irrational values or some fractional values. It is also difficult to plot such coordinates also onto the graph sheet. Okay, so that is the reason we are actually going for an algebraic way of solving the problem. In algebraic method, there are two important methods. One is substitution method and another is the elimination method. In this session, we are going to see some examples on the substitute method only. Elimination method we will see in the next coming sessions. Okay, so now what exactly is substitution method? As the name indicates, when two pair of linear equations are given, then the solution in substitution method is actually achieved by substituting the value of one variable into another equation. Okay, it means that with the given two equations, you have to first write one variable value in terms of another variable. Okay, and then substitute that into the another equation to get the other variables value also. Okay, so that is the way of substitution method. We will discuss that, the steps of the substitution method in detail. And in contrary to the substitution, there is an elimination method also. Elimination method, as the name indicates, it actually eliminates one of the variable or removes one of the variable from both the equations. Okay, and finds out the value of one variable. You can put that value into any of the two given equations to get the another variable. So that is how you actually get the solution in elimination method. See, as it says, it is the solution is achieved by either eliminating or you can remove also. And how do you eliminate or remove? It is by subtracting one equation from another or adding one equation into another. Okay, or by adjusting the equations in such a way that we get the solution for one variable. Okay, so that we can put that value into another variable and get the solution for both the variables. Okay, now without wasting much of the time, let us go with the example of the substitution method. Okay, so substitution method, and these are the steps of the substitution method. Okay, now let us follow these three important steps to solve this pair of equations. Okay, let us see an example. Okay, so first step, listen carefully. The first step in substitution method, find the value of one variable in terms of another variable. Okay, using the given equations. So first step is find the value of one variable, either x or y, in terms of the other variable. Okay, assuming this is our equation 1, okay, and this is our equation 2. So let us form the first step. I'll take second equation, because you can see that in second equation x is a single variable wherein I can find out x in terms of y by transferring 2y to right side. Okay, so I can say, see, I can say from equation 2, I can say that x is equal to 3 minus 2y. right? Just transfer 2y to the right side. So let us call this as equation 3. So first step is completed. What is first step? You have found the value of x in terms of y. Okay. Now second step, substitute the above calculated value. Above calculated value is the value that you calculated in first step in any one of the equation to find the value of one variable, either x or y. So it means that in second step, uh, you will substitute the value that you found in the first step in any one of the variable, any one of the equation. So since I have modified equation 2, let me put this value of x into equation 1. That will actually get us the value of one variable, either x or y. Now since I have found the value of x in terms of y in the first step, I will get the value of y here. Okay, first. Okay, let me perform the second step. Substitute. What I'll do is substitute equation 3 in equation 1, right? That is the second step in equation 1. So in place of x, see 7x, in place of x I will be putting this value. So let me write that 7 into 3 minus 2y, 3 minus 2y. In place of x I am putting that. So 15y I will write as it is equal to 2. Let us resolve this. So we will get the exact value of y. Okay, 7 3s are, that is 21, 7 2s are 14y, okay, minus 15y is equal to 2. Okay, so this will be, I will sum up these two, minus 29y, 14 minus minus 14 minus 15, 29y is equal to 2 minus 21, that is actually minus 19. Okay, so minus minus, let us cancel from both the sides. Then I will get y is equal to 19 by 29, 19 by 29, right? So I got the value of one variable, the exact value of that. Y is equal to 19 by 29. So that is the second step. You will either get the value of x or y. Okay. So I got the value of y. What is the third step? Substitute the value obtained in step 2 in any of the equation to find the value of the remaining variable. So what is the remaining variable for me is x to be found. So I can put this value 19 by 29 in any of the equations. There are 3 equations. So it is easy for me to find out the value of x by putting this into equation 3, because equation 3 is fully defined in terms of x and y. Okay, so now let me write that here only. Substitute in equation 3. Okay, assuming this is equation 4, substitute the value of y in equation 3. What is equation 3? That is x is equal to 3 minus 2 into, what is 2 into 19 by 29, 19 by 29, right? Y is 19 by 29. So what is this exactly equal to? 3 minus 19 2s are 38 divided by 29. Okay, so cross multiplication, it is 29 threes are, what is 29 threes are is 87, right? 87 minus 38 divided by 29. So what is 87 minus 38? Minus 30, 87 minus 30 plus 57 minus 8 is 49. So x is equal to 49 by 29 is the value of another variable. So x is equal to 49 by 29 and y is equal to 19 by 29. So this is what the substitution method is. Remember these steps, right? Okay, let us move to the next problem. We will achieve the solutions by using the same way. Okay, the problem here is not directly given with the equations to solve. Okay, so there is a descriptive problem given. We have to first form the two equations, resolve them by substitution method to find out the solution for this. Okay, now let us read the problem once and then we will form the equation. So solve the following equation. What is the description they are giving? Aftab tells his daughter. So there are two characters here, Aftab and his daughter. 7 years ago I was 7 times as old you were then. Okay, he is telling his daughter that 7 years back I was 7 times older than you. Okay, and 3 years from now, 3 years from now means plus 3 years. 7 years back means minus 7 years. Let us first read and represent them later. Okay, I shall be 3 times as old you will be. Okay, so represent this situation algebraically and graphically by the method of substitution. Let us first represent the Aftab's current age and his daughter's current age as x and y. Okay, so based on the current age, we can subtract 7 to go back 7 years, and we can add plus 3 so that we'll go after 3 years. Okay, or 3 years from now. Okay, listen carefully. Let Aftab's current age, so that is what is the variable x. Current age is equal to x. Aftab's daughter's age, I can say daughter's age, is equal to y. So in terms of x and y, if we are representing ages, then we can easily convert them into equations. So what are the conditions they have given? 7 years ago. 7 years ago, what will be the age of Aftab? If currently, if he is of x years age, then 7 years age before he will be x minus 7, right? So therefore x minus 7 is the age of Aftab 7 years back. Okay, so what is that is equal to? What is he saying? I was 7 times as old you were then. Okay, so what will be Aftab's daughter's age 7 years back? If currently she is y years, then y minus 7 only. Okay, so let me write that as y minus 7. But that y minus 7 was 7 times the age of Aftab. So this is my first equation. 7 times as older as his daughter 7 years back will be the age of Aftab 7 years back. Correct? Similarly, we can write this also. Let us first resolve this and then we can write that equation also. Okay. So x minus 7 is equal to 7y minus 7 sevens are 49. Right, take both these values to the left side. This equation will be x minus 7y, it is minus 7 and plus 49, that will be plus 42 is equal to 0. Let it be equation 1. Let it be equation 1. Now, what is the second condition they are given? 3 years from now. That means x plus 3 years. Okay. If currently x, then after 3 years it will be x plus 3 years. And what is that will be equal to is 3 times the age of his daughter after 3 years. Okay. So, and I can say x plus 3 is equal to y plus 3 times y plus 3. It is, let us resolve this, x plus 3 is equal to 3y plus 9. Let us move this 3 to the right side. That will give us x is equal to 3y, okay, plus 9, and it is minus 3. 3y plus 6. Now you observe here we have derived an equation to the x in terms of y already. So substitution methods, first step we have already achieved. You don't have to write that in the form of equation, because anyway after writing equation also, the substitution method first step we are going to convert that equation into the form and writing one variable in terms of another variable. That assume that we have already done it in this step. Okay, so x is equal to 3y plus 6 is the first step of the substitution method. Now substitute equation 2 into equation 1. In place of x you can substitute this, so that you will get the value of y. Okay, let us continue that. Substitute equation 2 in 1. Okay, what is equation 2? X is equal to 3y plus 6. Let us put that in place of x. So 3y plus 6, 3y plus 6 minus 7y. Let us write the remaining terms of that equation. Minus 7y plus 42, right, is equal to 0. Now resolve this. So it is 6 plus 42, 48 plus 48, and this is 3y minus 7y, it is minus 4y plus 48, right, is equal to 0. Okay, let us take 4y to that side and write it in a switch format. Okay, I will write, so therefore 4y, keeping 40 at this side and taking 4y to that side, is equal to 48. So what is y? Y is equal to 48 divided by 4. 48 divided by 4, and that is equal to 12. Okay, so y is equal to 12 is one value. So let us substitute y is equal to 12 in equation 3 to get the value of x. Okay, so substitute. Okay, let us write that yourself. I will just directly put the value of y in place of x. So x is equal to 3 into 12. 3 into 12. Okay, plus 6. So what is that? 12 threes are 36. 36 plus 6. It is x is equal to 42. So you write yourself the answer. Aftab's current age is x and Aftab's daughter's current age is 12. You can write yourself here. Okay, and you can verify that whether the ages x is equal to 42 and y is equal to 12 are satisfying this condition or not. That is about the equation, the example 5. Okay, let us quickly go to the next example. This is also a descriptive problem only. Okay, so let us read the problem. In a shop, the cost of 2 pencils and 3 erasers is 9. Okay, so let us underline this. 2 pencils plus 3 erasers is equal to 9. Let us underline the other part also. 4 pencils and 6 erasers is 18. Only two quantities given here. 2 pencils plus 3 erasers is equal to 9. 4 pencils and 6 erasers is equal to 18. Very simple. Okay, now what is to be found? The cost of each pencil and each eraser. So that is what our variables are. Okay, let us represent that. Let cost of one pencil is equal to x. Okay, or you can say rupees x. Okay, let us write that. Cost of one pencil is rupees x. and cost of one pen, one eraser, right? It is eraser, not pen. Cost of one eraser is rupees Y. Okay, since they are the values, the currency values, I'm representing it as rupees. Okay, now what is the condition given? Okay, what is the condition given? With x and y as costs given is 2 pencil plus 3 eraser, that is 2x plus 3y. 2x plus 3y is equal to what? 9. That is equation 1. Okay, let us write this as equation 1. 4 pencil, that is 4x plus 6 erasers, 6y is equal to 18. Right? Equation 2. Right? Now, if you look at both the equations, you will find that these two equations are coincident equations, or coincident lines they are going to create. Okay, so if you see a1 by a2, that is 2 by 4, b1 by b2, 3 by 6, c1 by c2, minus 9 by minus 18, all the ratios are equal to each other. So you are going to get the coincident lines, and coincident lines have infinitely many solutions. Okay, so it is difficult to find one solution for the two given pair of linear equations. So let us prove that in substitution method there was one more condition. There will be one more condition that we need to add when we solve this equation. And if you get a true value, okay, a true value, then it means that it has many solutions. Okay, so let us resolve this. Okay, even if we know that we are not going to get one single value for x and y, let us resolve this and find that whether it gives the true value. If it is true value, that is an additional condition for substitution method, that it has many solutions. If it is false value, then there is no solution for that. Okay, remember this also, or else if you have to add the fourth condition here. You have to add a fourth condition here in the substitution steps, that after solving the equations you get a true value. Okay, then the equations has many solutions, and if it gets a false value, then there is no solution. Let us add that point here. Okay, write it to yourself. Okay, let me go to the problem. Okay, now let us resolve this and follow the substitution step. The first step is define variable x in terms of variable y by considering any of the equations. So let me consider equation 1, and from equation 1 I can say 2x is equal to, keeping x, I'm taking y to that side, 9 minus 3y. Okay, and x is equal to 9 minus 3y divided by 2. Right, I will call it as equation 3. Okay, and substitute equation 3 in equation 2. I will, because I've derived x from equation 1, I'll put it into equation 2. Okay, substitute equation 3 in 2. Equation 3 in 2. So in place of x I will put that. Okay, 4 into 9 minus 3y divided by 2 plus 6y is equal to 18. Right? Okay, let us resolve this. 4 9s are 36 minus 4 3s are 12y. Okay, I will take the LCM here, so it will be cross multiplied, plus 12y. I'm going to get, it is 2 2s are here. Okay, and 2 I will take to the right side, so that is 18. Okay, let me write that first. Okay, so that there will not be any confusion. Okay, so that will give me, see, plus 12y minus 12y plus 12y get cancels. And what is the equation? What is the equation I'm getting? 36 is equal to 36. So 36 is equal to, you are not going to get the value of y directly here. We are getting a true value. 36 is equal to 36 is mathematically true equation, right? So we are getting a true value. So what is the condition in substitution method? If you are getting a true value, then it means that the equations are coincident and they have many solutions. Okay, so let us write that as a conclusion. Therefore, since the equations are resolved to true value, or you can say are resolved to a true value, resolved to a true value, the lines are, or you can say the equations are coincident. The equations are coincident. Okay, and have infinitely many solutions. Okay, infinitely many solutions. So you are not going to get one exact value of x and y in such situations. So this is what the solution for this problem. Now the second condition where you are going to get false. Okay, there might be any such examples. Let us see that. Okay, what is the example? Two rails are represented by the equations, given equations. Now you can ask me, how can the rails be represented by the equation? So assuming that those lines or those equations are represented by a straight line, we assume that those straight lines are rails only. And what is asked? Will the rails cross each other? What do you mean by that? If the lines are crossing each other, then it means that the rails will also cross each other. What is the condition of the non-intersecting lines in the substitution method? Okay, in substitution method we have to resolve these equations, and if you totally get a false value, then the lines are not intersecting, or you can say the lines are parallel. Okay, let us resolve the equations. The first equation is x plus 2y minus 4 is equal to 0, that is equation 1. Second is 2x plus 4y minus 12 is equal to 0. Okay, let us quickly follow the first step of the substitution, that from equation 1, since I have equation 1 x as a single term, I will write x is equal to minus 4. I will take it to that side, that will become plus 4, and plus 2y, that will become minus 2y. Okay, let us call this as equation 3. So I have defined x in terms of y by equation 1. Substitute this equation 3, substitute equation 3 in equation 2, right? In equation 2, let us substitute that. 2 into x. What is x? X is 4 minus 2y. Okay, plus 4y is equal to, or minus 12 is equal to 0. Okay, 2 4s are 8, minus 2 2s are minus 4y, plus 4y minus 12 is equal to 0. Okay, minus 4y plus 4y. 8 minus 12, what is that? Minus 4 is equal to 0. Okay, minus 4 is equal to 0 is false. I can say this equation is mathematically false because minus 4 cannot be equal to 0. So what did we got after resolving the two given equations? We got a false result. So if there is a false result, then this is not going to happen. Okay, what is asked? Will the rails cross each other? No, because we are getting a false result here. Okay, so let us write that conclusion. Therefore, since the equations are generating a false result, since equations are resolved to a false resolved to a false result false result result, they are not going to have a solution. They are not having solution, or we can say simply having a solution. There is no solution at all. Okay, so if there is no solution, this is not going to happen. Therefore, the rails will not cross each other. The rails will not cross each other. That is what the result is. Okay, why we are saying rails will not cross each other? Rails crossing each other is exactly equal to an intersecting two lines. Okay, so that will happen only if there is a solution to it. Fine. So this is about the example 7. Okay, now that we have discussed some solved examples on the substitution method, we can see some exercise problems also in the next session. Okay, let us continue on the exercise problems in the next session. Thank you.